Section 2.3, lines. We're going to find the slope of a line. We're going to write the point slope form of the equation, the slope intercept form of the equation. We're going to be able to recognize horizontal and vertical lines. We're going to be able to recognize the general form of an equation of a line and find equations that are of parallel lines and also perpendicular lines. The slope m of a non-vertical line is a measure of the steepness of the line relative to the x-axis, and it is defined as m is equal to the change in y over the change in x. So y sub 2 minus y sub 1 over x sub 2 minus x sub 1. And you could also do this, y sub 1 minus y sub 2 over x sub 1 minus x sub 2. The general thing is make sure that if you're starting with point 2, you're subtracting point 1. If you start with point 1, you subtract point 2. Slope is rise over run. Your rise is your y-axis, so it's a change in your y-axis. Your run is your x-axis, so it's your change in your x. Horizontal lines have a slope of 0. Because remember, a horizontal line is a y equals some number. So if you take the difference of those two y's, you always get 0. So you'd have 0 in the denominator, or numerator. So you'd have 0 over a number, which is 0. Vertical lines have no slope. And that's because your change of x is equal to 0. So you have 0 in the denominator. 0 in the denominator is undefined. Examples of lines with positive slopes. From left to right, they're increasing. Lines with negative slopes. From left to right, they're decreasing. The slope of a line, y is equal to mx plus b, is that m. So m is your slope. B is your y-intercept. Y equals mx plus b is referred to as the slope-intercept form. There's another form called the point slope form, which is y minus y sub 1 is equal to m times the quantity x minus x sub 1. And that's your point slope form. General form, ax plus by is equal to c. Your coefficient a would be a positive number, so move it to whatever side makes the coefficient of your x, which is a, the coefficient a, positive. Slope-intercept form, I already told you about. Your point-slope form is written like this, and it really comes from the equation of slope. Change in y over change in x. So if you want to write it like that, you can. I think it's easier writing it like the slope formula, personally. Vertical lines through a point HK has equation x is equal to h. Horizontal line is the equation y is equal to the y, which is k. What are the slope and the y-intercept of the line? 7x plus 13y is equal to 26. Easiest way to do that is get it into y is equal to mx plus b form. Because if you can get it in y is equal to mx plus b, remember, slope, y-intercept. So let me do that there. I have 13y is equal to negative 7x plus 26. Subtracted 7x. I want y, not 13y. So I'm going to divide by 13. So now my equation is y is equal to negative 7 over 13 times x plus 26 over 13 is 2. So my slope is negative 7 over 13. My y-intercept is positive 2. Parallel lines will have the same slope, but different y-intercepts. And here's an example. See, if lines have the same y-intercept, they will have different slopes. Two non-vertical lines are parallel if and only if they have the same slope. Same slope. So they're parallel if they have the same slope. They are perpendicular if their slopes are the negative reciprocals of each other. Negative reciprocals of each other. So that is if one slope is the negative reciprocal of the other. So if one slope is 1/2, the other will be negative 1/1/2 or negative 2. Or if you add the two, or multiply the two slopes together, they will equal negative 1. And remember, slope equation. I have 3 lines there, L sub 1, L sub 2, and L sub 3. I want you to tell me if these lines are parallel to each other, or perpendicular to each other, or neither. So the easiest way to do that is put each of the lines in y is equal to mx plus b form, and then you can easily see what the slope is. First one is already in that form. So there's my slope. The second one, remember I have 4x plus 3y is equal to 10. End up with 3y is equal to negative 4x plus 10, and divide by 3. So I have y is equal to negative 4/3 x plus 10/3. Slope is negative 4/3. And line 3, I will have 3x minus 11, so I'm moving the 11 to the left side. I'm moving the 4y to the right side because I wanted that 4y to be positive. And then divide by 4. And so your equation now, y is equal to 3/4 x minus 11/4. So now I have these slopes. Line 1, line 3, they're the same. So they're parallel to each other. So line 1 is parallel to line 3. Line 2 is perpendicular to line 1. Line 2 is also perpendicular to line 3. Find the slope of the line joining the 2 points. I don't care which point you start with. It does not matter. So I am going to start with the second point. I have 6 minus 0 over 3 minus 2. 6 minus 0 is 6. 3 minus 2 is 1. 6. You could have, don't do it both times, but I'm going to show you, I could have started with the first point and done 0 minus 6 over 2 minus 3, which is negative 6 on top, negative 1 in the denominator. Negative 6 over negative 1 is a positive 6. So the slope is 6, either way you do it. Find the equation of a line through 2 points. So I want to find the equation of this line through those 2 points. So let's see what you can do. Well, first of all, I could find a slope. So let me find a slope first. The slope is your change in y over the change in x. Rise over run. I did 4 minus a negative 2 over 1 minus 5. So I have 6 over a negative 4. 6/4 reduces to 3/2, so it's negative 3/2. You could have done negative 2 minus 4 and 5 minus 1, and then you would have gotten negative 6 over positive 4, which still reduces to negative 3/2. So now I have a slope. Remember there was something called the point slope formula. So you could use the point slope formula. It's not the only thing, but you could use the point slope formula. Either point, it doesn't matter which point you use. So I'm going to use the point slope formula with the 0.14. Okay? So you will plug in to the slope equation. My slope is equal to y minus my y over x minus my x. So it's y minus 4 over x minus 1 is equal to negative 3/2. And then what I'm going to do is cross multiply. So I take this right here, and you have a negative. This negative either has to go with the 3 or the 2, but not both of them, because if it were both of them, a negative over negative would be a positive. So I'm going to do it when I cross multiply with the 3. So I have 2 times y minus 4, negative 3 times x minus 1. That's what I have on each side. Distribute. So I have 2y minus 8 is equal to negative 3x plus 3. Negative 3 times negative 1 is positive 3. And then I'm putting it in the general form. So my x's and y's go to the same side. My integers or numbers that are strictly numbers go to the other side. So I'm going to add 3x and move this over. I'm going to add 8 and move that over. So you have 3x plus 2y is equal to 8. If you would have used the other point, 5,2, just so you can see, you get the same thing. So if you want to copy it down, pause it, copy it down. I'm going on. Find the equation of a line with a y-intercept of negative 3 parallel to the line 2x plus 5y is equal to 8. Different ways you can solve this. This is not the only way. But you could say, okay, I know y is equal to mx plus b. So I know that that y-intercept is minus 3. I do know that much. If it's parallel to the line 2x plus 5y is equal to 8, you know it has the same slope. So I can take that equation, 2x plus 5y is equal to 8, and put it in the slope-intercept form and then be able to read the slope from the equation, and that's what I'm going to do. So I'm going to move these over to the other side. So I have 5y is equal to negative 2x plus 8, divided by 5, and I have y is equal to negative 2/5 x plus 8/5. So now I know what my slope is. So let's plug it in the equation. Y is equal to negative 2/5 x minus 3. There's your equation in the slope-intercept form. If I wanted it in general form, here's what you could do to put it in general form. I want to get rid of that fraction. So I'm going to multiply both sides by 5. And then I have 5y is equal to negative 2x minus 15. 5 times y, 5 times that quantity. The 5's cancel out, negative 2x. 5 times negative 3 is negative 15. And then move the 2x over to the other side. So I can either have it in slope-intercept form or the general form. Linear regressions. In many applications, one way in which the quantity depends on the other can be modeled as a line or a linear function. So we can use something called linear regression, where we use a linear regression line or a least squared line to find the equation of the line that fits this data the best. So I have some years, 2006 through 2012. And each year I have the number of motorcycles that are registered in millions. So you have to define some x. So this will be my x, this will be my y. But x won't be 2006. I'm going to say the years after 2006. So x will be 0, because this is 0 years after 2006. 1, 2, 3, 4, 5, and 6. So we can put this in our calculator, and find the linear regression line of that. So let me do that. I can pull up my calculator here. And what you can do is push the button Stat. And then you want Edit, so I can just push Enter. And I have an L1 and L2. Nothing in them. If your calculator has something in it, go up so it's highlighted, and then push Clear and Enter, and you'll see the whole L1 column disappear. It'll look just like mine. So if you have numbers already in it, go up, push Clear, Enter. Okay? If you have it just like this, then you don't have to do that. In L1, I'm going to put my x variable. And remember, my x variable was 0, 1, 2, 3, 4, 5, and 6. And in my next column, I'll probably have to move this a little bit in a minute, I'm going to put what my y variable is. And so my y is 6.7, 7.1, moved over a little more, whoops, 7.8, enter, 7.9, oops, I made a mistake here. Look what I did. You see what I did? I don't want it on that same column. I want it on the next column. So let me clear those. Clear, enter, is that what it does? They clear it? Oh, let me clear the whole line. Now I can show you how to clear it with data in there. Clear, I'm going to clear the whole line and start all over again. Okay, 0, 1, 2, 3, 4, 5. And was there a 6 too? And there was a 6. 6. Now, in the second column, I want to put in my y variable. My y variable, 6.7, 7.1. I made a mistake. I didn't grab my 7. 7.1. Come on, 1. Yeah. 7.8. 7.9. Let's grab the other one. 7.9. What else do I have here? Oops. 7.9. 8488. So 8.4. 8.8. 9.5. Double check to see if they look correct. Also make sure that these are matched correctly. Sometimes people put in numbers quickly and mismatch it and forget a number. So double check to make sure it looks right. So now that I put it in, and on your notes you should have the descriptions here. In L1 put in your x, and L2 put in your y. Okay? To graph. Let me show you how to graph this. So if you want to graph it, there's something called stat plot, right up there, blue, stat plot. So I'm going to push this blue second key. So you do second, stat plot. Mine is off now. So I'm going to push enter to turn it on. And now I'm at plot 1. See how off is highlighted? It's blinking on 1. I want it, or on, I want it on. Here's different graphs you can have. There's a scatter plot, there's a line, there's a bar, looks like a box and whisker. So there's all different. You tell it where your x is, and my x is in L1. You tell it where your y is. Mine is in L2. And the type of mark you have. And then I can push graph. And there's what my graph looks like. Sometimes you won't see the graph at all depending on the data. I'm going to zoom in so you have a nicer graph. So I can do zoom. And there's something down a little bit called zoom stat. Zoom stat. So I'm going to push enter, and there it is. There is the plot of that. That's a scatter plot. And you can see, hey, it is pretty linear. I can put a line through it. So let's find the linear regression line. So to find the linear regression line, you push stat, and then you go over to calculate, and then there's something called lin, R-E-G, AX plus B. Go down to linear regression line, and I have a linear regression line, AX plus B, and if I push enter, there is the line, and I did not get the same thing, A. Did I make a typo? Let me look. Let me look at my data. Let me look here. Actually, I'll keep it there. Stat. Edit. 0, 1, 2, 3, 4, 5, 6, 6.7, 7.1, 7.8, 7.9, 8.4, 8.8, 9.5. Right, 9.5? There we go, much better. Stat, calculate, linear regression is 4. There we go. Easy to make a typo. Like I said, check your work or what you typed in. Obviously, I didn't check it. If you want that line to be graphed on the scatter plot, just to see how well it fits, you could do that. You could put the regression line into the equation, the y. You can put it in here, but you don't need to type it in. And let me show you what you can do. You can do vars. You can go to statistics. You can go over to the right to equation. And the number 1 says REGEQ. And there's my regression equation. And did it graph it? It should graph it. And it didn't graph it. So let me show you another way to do it. I don't know why it didn't graph there. I can do tests, and I know it'll show here. There's a regression equation test somewhere. There's a linear regression. I could do that. And I know this will work. Regression equation, I can go to vars, y vars, function, y1. I'm putting the linear regression equation in there, calculate. And there, it calculated it. And when you graph it, you'll see it now. If you want to know when x is 7, what the value is, you can plug x equals 7 into your equation, but there's a faster way to do it. You can look at table, which is blue, second table, and I can go up and down and see different x values. 8 is 10.2, 4.3, and so forth. 9, so there are the different values. So you can go up and down to find the value you want. And you can see this line's a pretty good fit. Okay? But that's fitting a line. That's the best fit line. Remember, as a review, horizontal lines have a slope of 0. Vertical lines have no slope. Parallel lines have the same slope. Perpendicular lines have slopes that are negative reciprocals of each other. Y is equal to some numbers a horizontal line. X is equal to some numbers a vertical line. Homework for this section, 1 through 8 all, 10 through 58 every other even, 59, 60 through 84 every other even, 106, 118.